lab we will study the equality. The symbol of equality are logical equality, logical inequality, case equality, and case inequality. These are the operators in Verilog code which are used in this. These operators compare the operands bit by corresponding bit for equality. Here is the some problems in this code. We copy this, simply copy this and paste into the Cortex software. We can see here the output is GH. First of all, we create the module and change the name exam3, and we see that here is the variable declare. Input is the 4-bit, ABCDEF are the inputs, and output is G and H. Here we can see the output is IJK also. So we change the I into L, and we add here GH, L, K, and I, J, and K. Here similarly here J and K. Here we also declare the output 4-bit 0 to 3. So here input declare and output is also declare 4-bit. G, H, I, J, K are the output. Here it declared the A and B are the default unsigned decimal, and C, D, E, F are the binary based number, in which some bits are undefined, unknown, which are denoted by X. In the first case, it show A is equal to B. We can simply see it here. A is equal to not equal to B, so it evaluates 0. In the second case, C not equal to D, inequality D. C and D, we can see there. C and D may be equal or may not. If X is replaced by 0, then it will be equal, and if X is replaced by 1, then it will be non-equal, so it evaluates X. In this C inequality F, C and F, they both are non-equal because the last two digits are different. It does not depend upon the X values. X may be 1 or 0. X may be same, and the last digits are not same, so it's evaluates 0. If not 1, it evaluates 0. So in the fourth case, D case equality E, D and E. Similarly here the last X depends upon X. If X is equal to 0, it depends upon X, so its evaluate also X. In the last case, C inequality D, C and D. C and D are the totally C case inequality D. C and D are the equal in the case case inequality, because it is different to this C inequality, C logical equality D. So it's evaluate 1 in this case, as shown in the manual. The case operands look for the equality also with the respect to the bits with unknown or high impedance. If the operand is shorter than another, it expands with zeros unless the most significant bit is unknown. So in case inequality, it's evaluate 1. Now we run the study. You can see there it is running. It takes some time to. We can see there the full compilation was successful. Now we go to the RTL view to check the circuit diagram. Here is the RTL view of this. Here is the 4-bit inputs IJKL, IJK and GH IJK, and here is the inputs. These are the operands, quality operands. Now we go to the university program VWF and insert the node here. We insert the node here, find node and list it here, copy it here and click on OK. Now we A and B are the decimal with undecimal. Here is the 4 and B is equal to 7 unsigned decimal. We will go to the B. B is also the unsigned decimal, value is 7. In the C, its value is binary 0 1 0. In D it has X10. Similarly in E we have value X101, and in D in F we have the XX01. We check this, check the value 010 and now we run this study. It takes some time to simulate. Here it shows the output waveform. At G it shows 0 0x 0x1. We check in this 0x 0x and 1. It will perform successfully, and that's all for this. Now we go to the next problem. It shows the logical inequality, and now here is the exercise. We have to evaluate these functions. For this we have to write the Verilog code. Now we go to the here we select the Verilog HDL file. Here we write the code module ex3, for which is the file name, and declare the variables. Let A, B, C, D, E, F, G, H, I, J are the variables. Now we declare the inputs. 4-bit input 0 to 3, A, B, C and D. We can change this according to our requirement, and we simply E, F, G, and J are the outputs. Now here we declare A is equal to, we assign the values simply copy these all and paste it here. We set this a is equal to this, b is equal to this. Now c is equal to this. Because these both are equal, we can also define this as d is equal to f is equal to b101x. b101x and b101x, these both are the same. We have no need to declare this. Both are the f. b101x, it has also f. b101x, it has also same f, but have the different cases, inequality, case in logical inequality and case in logical equality and case equality. So we have the ABCD and F. ABCD, we declare it E. ABCD are the inputs, and FG read this. Now we assign here A, B, C, D, E. F is equal to this is the function here. We assign f is equal to here this is the a, and this value is b. A logical inequality b. Similarly, we assign here again g is equal to b001c logical equality c logical equality. This is b1d. So now here we again assign n is equal to here b101x have the value of e. Here we write e is equal e logical equality. Here for b101x is also e, so it's evaluate 1. Here we again assign j, which is equal to e case equality e. In this case a and b, its evaluate 0, because both are no. It shows the logical inequality. It shows its evaluate 1 because it is true. In this case, C equal to D. Both are the equal because it have here we can also write 0 0 0. So both are the equal, so it's also evaluate 1. So here E logical inequality to E, both are this equal, so it's also evaluate 1. Here also similar, evaluate 1. In all cases it's evaluate 1. Here we end the module and run the study. Here it shows some error. We will check. Here we change both side equality. We declare here again F is equal to H is equal to B4. Similar, copy this and paste it here, and we write it E is equal to H. Now we run the study again. We declare here H also. Now we run this study. It show error again. Here is the mistake. We have to write it there, and we run this again. Now he is running successfully. It takes some time to compile. We can see that the full compilation was successful. Go to the RTL view. Here is the RTL view of this. It has the A, B, C, D and E, H are the inputs, 4-bit inputs, and these are the outputs, and with the equality operands. Go to the university program EWF to perform the here we insert the nodes, node finder, list it here and paste OK and OK. Now we assign the values here. We can see A is equal to B101. Similarly, we go to that there. We assign the values now. Here A is equal to 101, 1, 0 and 1. B is equal to 0, 1, 0, 0, 1, 0, and C is equal to 0, 0, 0, 1. D is equal to D is also equal to 0, 0, 0, 1. E is equal to 1, 0, 1 x, 1, 0, 1, and here we write x. 101 x, and E is the input. Here H is also the input. H is equal to 101 x, also 101 here is the x. We take this here, a b c d e h are the inputs. We recheck this. A is equal to 0 1 0, b is equal to 0 1, a is equal to 0 1 0 1, b is equal to 0 0 1 0, c is equal to 0 0 1, d is also equal to 0 0 1, e is equal to 1 0 1 x, and h is equal to 1 0 1 x. Now we run this study. It takes some time to simulate. Here is the output of this. We can see there it shows the output. In all cases it show f and g are the 1. We go to the here, f and g are the 1. Here we can see that e is equal to h, both are the equal. It should show logical inequality, and e and h. E and h are both are not equal, because e and h both have the x values. In e it may be 0 or 1, in h it also may be 0 or 1, so it's not evaluates 1, it's evaluates x unknown, because it has 0 and it has if e has x is equal to 0 and h has x is equal to 1, so these are not equal. Similarly, in this case it also show x, and similarly the output is equal to 1 1 x x, that's shown here, 1 1 and x x. That's all for this exercise.